12.4 volumes of prisms and cylinders. Starting off with the volume of a cube, since all the sides are the same length, volume of a cube is the side length cubed. Okay, and what we're going to do is we're going to measure volumes in cubic units. We're going to see how many these cubes fit in the total. Volume congruence postulate says if two polyhedron are congruent, then they will have the same volume. And it's a postulate because it should just make sense. They're the same shape. They'll have the same volume, shape and size. Volume addition postulate says you can add volumes together. Volume of a rectangular prism would be the length times the width times the height. And we'll talk a little bit more why that is in a second here. Cavaliere's principle: if two solids have the same height and the same cross-sectional height at every level, then they have the same volume. So basically what that's saying, if I had a rectangular prism and I tilted it so it was off-centered, now this is kind of a bad drawing, but if they had the same height but the square bases were the same all the way up, they'd have the same volume. So basically what happens is the volume of prism is the base area times the height, and this formula does not have to be a regular prism. Like for the pyramid, the base doesn't have to be regular, and this thing can be slanted. The volume will be the same. So volume of cylinder, if we take out the base area and call it the circle, pi r squared, you get, that's my base, the circle, times the height. It's the same formula, just different. Just like with that rectangular prism, the base of a rectangle is base times height. So that's where we come up with length times width times height using that fact. All right, find the volume of the prism. Volume. Notice I always start by writing my formula because there's so many formulas it's important to know. The base is a triangle, so that's going to be 1/2 the base times the height, base area. And the base of this triangle, you find that right angle. So 6 times 8 times 1/2, you get 24. And the height is the distance between the two bases. Okay, this is my height, the distance between 9. Notice this is not used in the problem. Not used. If we were finding the surface area, we'd need it, but it's not used for volume. So our volume is 24 times 9, which equals 216 meters cubed, cubic meters in this problem. Okay. Volume of a cylinder, base area, pi r squared times the height. So r being 5 and the height, the distance between the two bases, it can be horizontal. The height is 12. So pi times 5 squared times 12. Putting that in the calculator, 942.5 kilometers cubed. Now, given a volume equals the base area times the height, we're going to solve for x. So the volume's 90. The base area is x times x, or x squared, times the height 10. X squared, divide both sides by 10, equals 9. So x has to equal 3. We're going to throw out -3 as a possible solution because it's a length here. The last example, we want to find that the weight of this concrete block. So since it's 145 pounds per cubic foot, I need to multiply this by the number of cubic feet to get an answer of pounds. right? My cubic feet will cancel and I'll be left with pounds. So what is the um, volume of this cylinder, um, concrete block? So I have to basically find the volume of the big rectangle, and using that volume addition postulate, I can actually subtract out the two missing rectangles. So I'm taking the volume, since it's a rectangular prism, 0.66 times 1.31. It's going to tell me the area of what I'm going to call the base. Now I have to multiply that by the height, which is also 0.66. So it doesn't matter if you call this the base or this the base. 0.66 times 1.3 tells me this base times the height. And that's going to be the volume of all of it. Then I'm going to have to subtract out something. 0.570 feet cubed is the volume of everything. But now I have to subtract out what I'm missing. This is 0.33 feet. Oops, 0.33 feet times 0.39 feet times the depth again. The depth is still 0.066. And now I have two of those. So I'm going to take that times 2. So we get 0.169. And taking the volume of everything minus the two parts we're missing, we get a volume of 0.401 feet cubed. So like I said before, up here I'm going to have to take that and multiply it by 145 pounds. So taking my answer times 145, and I get 58.1 pounds. That's how heavy that cement block would weigh. So here's your homework assignment. Now I gotta make like a tree and leave.